Welcome back. In this video, we're going to explore the relationship between temperature and kinetic energy and learn how to convert between different units of temperature, including Fahrenheit, Celsius, and Kelvin. So temperature is a measurement of the average kinetic energy in a given substance. When you look at molecules, if you could zoom in on the molecular level, you would see that they are always in constant motion, which means that they always have some amount of kinetic energy. And this is true for all objects. Take a look at something that's solid around you, maybe your desk or your computer. Those little molecules that are part of that object are actually moving around. They have kinetic energy. And so temperature is a measurement of that average kinetic energy. Three common units exist that you will encounter in this course and probably throughout your life. Those are Fahrenheit, Celsius, and Kelvin. There are actually multiple other scales that measure temperature, but we won't be examining them in this course. Celsius is frequently used in the sciences. And in fact, the United States is the only large country left in the world that still uses the Fahrenheit scale. So being able to convert to Celsius and from Celsius is essential for work in sciences, in medicine, working in international communities, and just being able to understand the world around you. So to calculate degrees Celsius from Fahrenheit, you take the value in Fahrenheit, you subtract 32 degrees, and you multiply by 5/9. If you wanted to convert from from Celsius to Fahrenheit, then you can just rearrange that equation. To convert from Celsius to Kelvin, it's much simpler. We just add 273.15 to the value in degrees Celsius. Now let's talk a little bit about these scales and where they come from or some common values that you can find in them. So Kelvin is probably one that you're least familiar with. The Kelvin scale sets 0 as being the absolute lowest theoretical temperature that one could achieve. And that would put then 0 as a temperature that you can never actually get to. But if we could suck out all the energy and pull out all the kinetic energy from a given substance, then it would reach absolute 0. So in Kelvin, water freezes then at 273 degrees. The average body temperature is about 310 degrees Kelvin. And then water boils at about 373 degrees Kelvin. Fahrenheit is the common scale used in the United States. It dates from the early 1700s, and it was actually arranged around body temperature on the high end, and on the low end, the freezing point of a mixture of water and various salts. And so within Fahrenheit, water freezes at 32 degrees, water boils at 212 degrees, and the average body temperature is about 99 degrees. For the Celsius scale, sometimes also called centigrade, water freezes at 0 degrees, water boils at 100 degrees, and the average body temperature is about 37 degrees. So let's work on a problem here in just a moment, but the last thing to mention here is that is heat. Heat is a form of kinetic energy, and it transfers between two objects. And it does this when they're at different temperatures. So if you have a substance that's at a high temperature and a substance at a lower temperature, then heat energy will be transferred from the substance with the high temperature to the low temperature substance until they are at the same temperature. We call that thermal equilibrium. All right, now let's try a problem. So let's say that you're a nurse, you're taking the vitals for a patient, and you want to measure the temperature of that particular patient. You do so, you find that their temperature is 38.5 degrees Celsius. Now, they're not familiar with the Celsius scale. They'd like to know what their temperature is in degrees Fahrenheit. I'd like for you to pause the video and try to solve this one on your own. Once you do so, come back and I'll walk you through a solution. Welcome back. So how would we do this? Well, let's start by looking at the relationship between degrees Celsius and Fahrenheit. We saw this on the earlier slide. Now, let's rewrite it here, and what we're going to do is we're going to manipulate it. We need to convert from Celsius to Fahrenheit, so we're going to need to solve this equation 4 degrees Fahrenheit. The way that we do this is first by multiplying by 9/5. When we do that, on the right side, that cancels out, and we're left with 9/5 degrees centigrade equals degrees Fahrenheit minus 32, at which point we can add 32 to both sides, simplify, and then we get 32 degrees plus 9/5 of the temperature in degrees Celsius equals the temperature in degrees Fahrenheit, at which point we can plug in our value, 38.5 degrees Celsius, multiply that by the 9/5, we get 69.3 plus 32, add those together, and we get 101.3 degrees Fahrenheit. So clearly this person has a fever. Another way to solve this would be simply to plug in the value of degrees Celsius first, and then multiply and by 9/5 and add the 32. So how I showed you here, I solved 4 degrees Fahrenheit and then plugged in the number. Another way would just be to plug in the number and then solve for degrees Fahrenheit. So that's it for this video. Thanks for watching.